In this video we're going to look at different ways of presenting data, and the first way we're going to look at is the stem and leaf plot. This is going to be a double stem and leaf plot, okay, because we have two sets of data. We have room 1 and room 2. What these rooms are is just the age of people in that particular room. So in room 1 we have a 10-year-old, an 11-year-old, a 1-year-old, and so on. In room 2 we have a 1-year-old, a 7-year-old, a 3-year-old, and so on. Okay, so stem and leaf plot, here's what we do. Let's just take room 1 first. And here is going to be our stem, and the first number in each of these is going to go in our stem. So for instance, let's just take our biggest number, 31. Okay, so that would be just a practice one. 3 will go in here, 1 will go outside. Okay, we're going to start off with our smallest number, and that's 1, so it's going to be a 0 here and a 1 out there. So that's done. The next one is a 7, so 0 in there, 7 out there. Then we have an 8, so 8 out there, 0 in there. We're done with all the 1-digit numbers, so we go down to the next. We have a 10, so that'll be a 1 in here, a 0 here. We have another 10, and we have an 11. We have a 14. We have a 17. Then we have a 24 and a 31. Okay. Now, if it was just one set of data, we'd leave it at that, right? We would go the stem and then the leaves, I suppose, all to the right. But we have a second set of data here, and we want to compare both. So we're going to put the second set over here. Right. So lowest number we have is a 1. So 0, 1 is 1. We have a 2. We have a 3, we have a 4, we have a 7 and a 7, we have an 11, a 14, a 19, and a 21. Now we can compare both sets of data, and we can see here that generally this is a younger room over here, because look at all the people that are under the age of 10. Okay, so there's our presenting data, stem and leaf. Let's say the very last thing, we need to tell people what this actually means. So we need to put in a key. And I will just take, you can take any number, but 3-1, so I'm taking this here. So 3-1 equals 31. So what I'm saying is that there means 31. Okay. Next we have a bar chart. And I've just set up the bar chart, and how you set it up is, first of all, very important to have a heading, a main heading. Cake sold by a shop. The data up here shows cake sold by number of cakes sold in a shop on the different days of the week. Very important to label your X and Y axis. I have number of cakes sold here. I have days of the week here. Right, now when you're doing this, you use a ruler, okay? But for time's sake, I'm not going to use it. So on Monday we sold 10 cakes, so we'll go up to 10 there, and we'll draw a bar. On Tuesday we got 14 cakes, so, and on a bar chart we don't join up or stick these bars together, okay, there is a gap between them. 7 then here, so 7, on Thursday is only 3. Friday 19, on Saturday 27, and the bars again, as I said, they should be drawn with a ruler. They should also be the same distance apart and the same width, but for time's sake I'm not going to use a ruler. Okay, and that's that done. Okay, next up we have a histogram. Histograms are like bar charts, except they deal with continuous data. So for instance, in bar charts we have set numbers. So if you look here, 10, 14, 7, 3, 19, 27, 4. However, in histograms we have this more continuous based data, so 0 to 10, 11 to 20. Okay, they work the exact same really as each other, except I suppose the histogram has the bars stuck together. That's really the only difference. So here we go again. You should use a ruler. I'm not going to. So 0 to 10 take us up to 4. 11 to 20 is 7. 21 to 30 is 10. 31 to 40 is 7. Is 7. Okay, so that's that done. And remember again to label your x and y axis and all your histogram. If we were asked to find the mean, the mode, the median, the range, different things like that, standard deviation, we could use this, but in actual fact it's easier, I think, to use our frequency table. So if they give you this and they asked you to find the mean, the mode and the median, I would draw a frequency table from our bar chart first and then do it. Okay? Okay, so next up we're looking at drawing a pie chart from given data. So in this data it's the teams that people support. So we have 100 people and here's the teams they support. So 25 support Tipperary, 17 Waterford, 31 Kilkenny, 14 Wexford and 13 other. What we effectively do with this is we first find a fraction and then we multiply a fraction by 360. So for instance, 25 people support Tipperary, that's 25 out of 100, so there's a fraction. I multiply it by 360 to change it into degrees and we will get 90 degrees in this instance. When you're doing it, please draw it with a ruler and protractor, but there's our 90 degrees. Make sure to label it Tipperary. Next up then, so there's Tipperary, next up Waterford. So 17 out of 100 multiplied by 360, which will give us 61 degrees, which is probably about there, but again you will be using your protractor. Okay, next up then is Kilkenny, so it's 31 over 100 multiplied by 360 equals 112 degrees, which is about this much. Okay, next Wexford, which is 14 out of 100 multiplied by 360 degrees, which equals 50 degrees, which is about, I suppose, this much. That's Wexford. And last up then, other, which is 13 out of 100 multiplied by 360 degrees equals, gives us 47 degrees. 47 degrees, and that's other. So there's our pie chart. Okay, just one other thing. Sometimes they mightn't give us this information, but they might give us the pie chart. Okay, so we work backwards. They give us the pie chart. They say there's 100 people in total, and they want to ask us how many of those support Tipperary. This time we're starting off with the pie, so rather than putting a fraction of so many people over 100, we'll be putting so many degrees over 360. Okay, so we're looking at how many people support Tipperary. So this time we'll put the fraction 90 over 360, and then we multiply that by the 100 people. You will get 25. Okay, and so forth. So if we're going to find Waterford, 61 over 360, and then multiplied by the 100 people. If there was, let's say, 70 people, Well, then instead of having the 100 here, we have multiplied it by 70. Okay. Okay, so the last one we're going to look at is a trend graph. Here's a trend graph, and I suppose a trend graph, it shows a trend really, I suppose as the name suggests. This is a trend graph of a cyclist, and they're after going for a cycle, and they're after going away from home, they're after taking a break, and they're after coming back from home. So as it says here, distance from home, the times after taken. So on the x or the y-axis, I have distance from home in kilometers, and there it is. There. And then I have time in hours. So, for instance, after 1 hour, if we go up like that, I can see that they were 10 kilometers from home. And after 2 hours, then they were 50 kilometers from home. And look at this, after 3 hours they were still 50 kilometers from home, which means they must have just stopped and had a break there. And after 4 hours then they got home. Right, but we can see then we're not just limited to after 1 hour, 2 hours, 3 hours and 4 hours, because I can look and I can see how far they were from home after 1.5 hours. Okay, so it's about 29 kilometers from home. Also, the steepness of the slopes will suggest the speed. So if the slope is very steep, then they were going fast. So if you look for the first hour, it's not very steep, that slope, so he probably wasn't going that fast. However, from hour 1 to 2, it's a steeper slope, so he was going faster. A straight flat line like that with no slope means they were stopped, and then again a steep enough slope there, showing that he was going pretty fast. Okay, so hopefully that I suppose is some bit of use to you guys. Thanks.